Hi, um, welcome back to my Texture IT channel. So in this Kafka intro question session, we are going to cover about um, the performance tuning in Kafka. Right? So basically in Kafka we have three layers: producers, consumers, and brokers. We have to tune all these three layers to improve the performance. But in this session, we are going to cover only about improving or fine-tuning the performance on the producer side. Okay, so the objective of this question is to understand how good knowledge or hands-on the candidate has, in case any production issues comes as part of the performance issue, right? So if there is any performance issue, how he is approaching them, right? So that is the objective. Okay, let's get into the detail. Okay, so before getting into the actual solution, we need to understand how the producer is sending the data to the topic. What are the different things that is happening when the producer sending the data to the topic, right? So we are understanding that we know what are the different places we can actually fine tune, right, to send the data to the broker. So I'm just covering at a very high level. Actually, there are many things happening on top of these things, but I'm not going to cover all those things. I'm just covering at very high level from the performance perspective. Okay, so when the producer send a data, it will be serialized first, and then the Kafka applies the partitioning logic to find out to which topic or partition this message need to go. Okay, and then those messages will be buffered. Okay, those are not yet sent to topic, those are just buffer. Okay, and now we have a center thread. Okay, there is a separate thread called a center thread, which is actually waiting for some signal, to send the message to the respective topic, right? So what is those signals, right? Basically in Kafka we have many parameters that are available, by default. Okay, so some of those parameters are customizable. Okay, so few of those parameters we can use to improve the performance. Okay, so one of those parameter is the batch size, and the other one is linker.ms, which we are going to discuss now. Okay, so what is the batch size? Batch size is about how many bytes of data to collect before sending messages to the Kafka broker. Basically, let's say when I say batch size is 100 MB, and the producer is sending 100 messages, and each messages, let's assume, like occupies 1 MB. Then the center will wait for all the 100 messages to come, so that the batch size 100 MB, right, is met, and that will trigger the center to send a message to the topic. Okay, so the center is just waiting for the messages to reach the size which is configured in the batch size. Okay, on the other side we have a linker.ms. Okay, so this is basically the time interval between the message which was sent last time and the message and the time the next message need to be sent. Okay, so it's a time interval between those two parameters. That means, like, let's say, like, when I configure it as a 5 second, so the center message will wait for the 5 second to send the new message to the topic, to the broker. Okay, so it's a combination of one of these two, right? So either the center will wait for the batch size to meet a limit that is configured, or it is wait for the interval time to meet the limit that is configured in the linker.ms. So once one of these two parameters meet configured value, the center start sending the message to the topic. Okay, so what is we actually achieving because of doing this, right? So that's another question. What are we going to achieve with this? Let's say, okay, the same example, right? 100 messages the producer is sending to sender, right? It's buffered. The 100 messages buffered. If without this parameter, what is happening? The center, once it get a first message, it will send a first message to topic. Once it get a second message, it will be sending a second message to topic. Similarly, it will be communicating for every message to topic. Like for 100 messages means 100 times it will be sending the messages to topic and getting the response back from the topic, right? So there is too much of things happening over the network without these parameters, right? So which impact the performance by having a high latency. Okay, the latency will be high. Okay, so that is why what we are trying to do here, we are trying to accumulate the messages in batch and send all those messages in one batch. Let's say if I configure the batch size as 100 MB and each message is 1 MB, then all the 100 messages will be accumulated as one batch and sent at once to the topic. This way, I am trying to improve the latency of my producer. Okay, so that's a one way of improving, fine-tuning, the performance. The other way is, so apart from the batch size and linker.ms, what are the other things we can do to improve the performance, right? So then other one is, the other parameter we can think about is serialization. Okay, having a very good serialization in place to send the data to over the network, right? So it is always recommended to serialize the data before sending the data over the network. Okay, there are a lot of, by default, Kafka is providing you lot of serialization mechanism. On top of that, we can also have our own customized serialization code logic to serialize the data and send to topic. Okay, so serialization is must whenever you send the data over the network. Okay, and apart from that, we do compress the data. Okay, in the buffer area we do compress the data. So by default, the Kafka supports snappy or gzip compression. Okay, we can also have our own compression mechanism to compress the data. The compression is must because you are going to send, in a batch mode also you are going to send too much of data, right? So instead of sending too much of data at once over the network, it is better to compress them and send it. So the transmission will be fast over the network. This is to improve the throughput, right? So to process the message fast, right? So the compression is used to improve the throughput. Okay, and apart from that, okay, so here what I'm trying to say is the throughput and latency are inversely proportional, right? So we always need a low latency and high throughput for a better performance, right? So those two are inversely proportional. We can achieve, we always need, whenever we work on the performance tuning, we need to think about either having a less latency or high throughput. Okay, achieving both, right? it's a bit critical process, but yeah, we can do that too. Okay, so that's a concept of having this chart in here. Okay, so apart from configuring the batch size and linear size, serialization, compression, okay, there is one last thing we need to think about. Okay, is what type of acknowledgement we can use, okay, to improve the performance. So the acknowledgement ACKS, okay, it's based upon how I send, right? It's like there are multiple ways, whether I send and just ignore, like I don't care about what happened to my message, how much I care about my messages, right? I send and how much I'm going to care, right? So that is nothing but this acknowledgement. Okay, when I say 0 means I am just sending the message and I never care about that. Okay, and when I say 1 means, okay, I sent a message, okay, but the broker, we have there's a concept called replication, which I'm not going to cover in this discussion. Okay, so in the replication, what will happen, I'm just going to copy the data from one broker to another broker, okay, and that broker will be used in case of failover. Okay, so when I when I say the replication factor is 2, one of the broker will be leader and another one will be just the slave. Okay, it's a backup broker. Okay, so when I say the ACK as 1, okay, the producer just want to make sure at least the data reach the leader broker. Okay, the topics which were there in the leader, okay, received the message. Okay, it doesn't care about whether that actually reached the replication, right? So that is the acknowledgement 1. Okay, acknowledgement -1, we can also say all, means the producer want to make sure that message reach all the brokers, the leader and also the backup brokers, right? And after getting the acknowledgement from everyone, okay, the producer will make seems like okay, okay, my message reached all the brokers, right? So that much of so it's all based upon how reliable you want, right? So whether you care about the data or you are less reliable on data or more reliable on data, right? So based upon how you configure this, you need to trade off between how much throughput you want and how much latency you want. If like in case if I'm going to with a 0 acknowledgement, which means like I just enter data and I never care, which actually help you give more high throughput, okay, with low latency, which is actually a very good performance in terms of performance. But your data, you cannot rely on your data, like whether it reach or not, like that is not sure. Okay, so in that environment you can go with 0, but if you go with 1 means both the latency and throughput will be on the medium level. Okay, yes, the producer will be waiting for the acknowledgement from the leader broker, right? So there is a few seconds of latency, and because of that latency, even the throughput will be medium. Okay, and if you want to wait for all the brokers to respond back saying that we got a message, in that case, okay, the latency will be very high. Okay, and latency will be very high. Latency will be, in that case, the latency will be very high. Okay, which actually again impacting the performance. Okay, so you need to design your application in such a way what you want, right? And accordingly you can make use of one of these configuration. You need to trade off between the latency, throughput and reliability of your message, right? So you need to trade off between all these 3 parameters to choose the performance of your producer. Okay, so These are the different ways of fine-tuning your producer in Kafka Vault. I hope you all got it. I will have one more session about improving the performance on the consumer side. Till that, if you like this video, subscribe to my channel for the future videos, update from the future videos. Thank you.